Okay, so I'm going to show you my secret circuit for building a zapper in this economic, smaller, cut down size. So I've removed the negative positive channel from the right and I've cut it in half. So that is now a very small breadboard. And I'm going to show you the 555 CMOS timer has a little bite out of it on the top. So there's either a circle or a little mark, but you can see right here is this little circular bite, and that's the top, so that you know your pins are 1, 2, 3, 4, 5, 6, 7, 8. So you just want to know the top, because if you have it upside down, it's all wrong. So look for a cookie or a circle, but they call it a cookie bite, and it's usually just a mark designating the top. So I'm going to push that into place. Now I am going to do about 5 dots down from the top. I'm going to cross this middle channel. So because the numbers are right, I mean, 5 will work for us. When you're doing the bottom piece, you're going to have to count 5 holes down because the numbers are not the same anymore. So here we have, I'm doing it at 5 channel, and it just bridges the gap between this channel. So it's E5 to F5 and downward. Just make sure your cookie bite is at the top. It's hard to see. I'll let go. So you can see that little cookie bite right there that designates the top. Very important. Now I will be clipping some of these short. So the resistors, here's a 1K, brown, black, red, gold. It goes in tight right there, so I can just bend this straight down right off the resistor. And then I'm gonna cut it so that these aren't so long. I don't need them that long. I just need them to be enough to get into the breadboard. So see how it looks like a staple? It's about the size of like that. So this would go from 5 to 6. So I go from G5 over here to J6. And that's connecting pin 8. Now that's how this goes 1, 2, 3, 4, and then 5, 6, 7, 8. So this connects pin 8 to pin 7 just by coming down. These channels are all connected this way. So all 5 of these are connected together. And that's how this works. So anything in the 5 channel is connected together. So that means this pin is connected to 5, and then this pin is connected here to the other end at 6. Pretty cool, right? So now we're going to put this yellow, violet, red. I gotta find it. I can't see. Oh, that's red, 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 red. Yellow, violet, red. Let's see. That's it. Yellow, violet, red. And that's going to go, same thing, it's going to go down in 6, and it's going to connect to 7. So I'm going to cut this just like a staple as well. And this is going to go in at F6, and then it's simply just going to come here to J7. And that just pushes in like that, real easy. Now the capacitors. Here are the 2 capacitors. Tear them off their piece of paper. There's 1, there's 2. So get all the stuff off of them so it's conductive again. Okay, and then this is going to let's see. These two go, I'm gonna start off with G8 to G12. So G8 to G12, it's right there. So there's a capacitor. And I've got to do one more right behind it, really close. This stuff's hard to get off. This has to be clean so that it's conductive. You don't want that paper messing up your project. So just use what you got to clean all that paper and sticky stuff off. Expose the metal. And then this one's gonna go to H7 to H12. So H7 to H12. There, get that in there. Those are the two capacitors. I'm gonna lay them down a bit so they're not there. Very good. Now, this is an optional piece. It doesn't come with a kit. This is what protects your battery if you touched it backwards. So this little diode just protects your circuit from getting fried if you touched the battery. When you're changing batteries, if you touched it backwards to where you're supposed to connect it, it could fry your CMOS timer. So I'm going to add this protective thing that does not allow any of the electricity to run backwards through this circuit. This is just a one-way circuit. So you can see that it's orange and that one end is black. So let's see if you can see the black, how it's an orange little root beer barrel. Tastes good too. It has a black end, and that's the grounded end. So that grounded end has to go to J5, then the other end will go to J2. So I'm gonna get this down into J5 and into J2, and I'm just gonna push it into place. Now your circuit's protected with that diode. Now I gotta put another 1K, because there's a brown, black, red, brown 1K right there. I gotta put another one, so I gotta find its matching one. Yep, brown, black, red, that's easy. It's another short distance, so I'm gonna cut it just like a staple once again. Here we go. Now, this goes from C7 to C4. So the channel of C from 7 to 4 is got a 1K resistor. There it is. Now this all red one, this one travels a little bit further. This is going from B1 to B7, so it's bigger than a staple. I'm just gonna judge it. Let's see, from 1 to 7, yeah, it's about right. So I'm gonna cut off the bit so that this can stick into the breadboard. B1 to 7, so I'm gonna stick this into B7 and then B1. Those just go into place. B1 to 7. Now the positive offset, orange, white, what do we got? Orange, white, orange, gold. This is what makes the whole circuit positive offset, so you've got to make sure and have one of these. This is part of the real function of the zapper, is this resistor right here, and this goes from A4 into the plus. And that's a short distance, so I can just make this into a staple. Cut off these extras. And I will do A4 to the plus. So A4 all the way to the plus channel, right there. So anywhere in that plus channel will put you into the positive channel. So that's the resistors and the capacitors and this diode. So all this is set. Now I just need to add the LED and the wires. Now any LED that's a 3-volt LED, almost all of them are. They come in different sizes. This is a small one. This is a little bit bigger, but it's still a 3-volt LED. And the rest of these can go in either way. It doesn't matter which end is which. There's no positive or negative other than this one that had the black end. But this has, obviously you can see how one leg is longer than the other. The long leg is the plus, the short leg is the ground with all LEDs. So that's how you know which one is the ground, is the short one. So you just have to put it in the correct place. So the LED goes short leg into the negative channel over here, and then the long leg goes in E1. So I'm gonna put this in E1, and I'm gonna come over here to the negative ground channel, and I'm just gonna put them in place. There. So now I have an LED. So now I got to hook up all the little wires, and I'm going to just use these jumper wires, and I'm going to cut them up because I want to show you a really cool tool, is this wire stripper. Now I'm just going to show you how the wire stripper works. If you have wires that have been cut and you need to expose the wire inside, this tool allows you to adjust this bump. This bump goes back and forth. And so if I put my wire right there, it's going to strip about a breadboard's worth, the way I have it set. In just one motion, I'll be able to do that. So this is stranded wire. I'm going to have to solder this just to make it stiff. So there. I have, very nice. Isn't that satisfying? It's so fast. So I'm going to twist these stranded wires just so that they're a little bit sturdier, because I got to push them into the breadboard. So I'll just make them sturdy by wrapping them. There. Now, a lot of on-off switches have 3 prongs. And what I would explain is you can use it this way. The middle one will be your ground, or and then you can use one of the other 2. So you can solder to the middle one, and then use one other one, and the one that's not soldered will be your off position. And the way a switch works is it's like a teeter-totter. If it's up, it's connecting these 2. If it's down, it's connecting these 2. So if I only solder the power to 2 of them, the empty one will be off. There's no power, nothing connected to it. So it will become an on-off switch by only using 2 of them. So I'll show you that. What I'm going to do is I'm going to split the power up. So instead of putting the power directly into the circuit, so I'll show you what happens here. Once you power up the circuit, of course, you would put the battery into the plus and minus down here, and you get the LED to light up. But if you want to switch, you just want to take the red, solder it to a switch, and then solder the middle one to a wire that you plug in there. So then you can turn it on and off, and all you've done is really just split this red wire from getting to that red channel with a switch in between. So I'm going to solder this in place over at my solder station. So why don't you come with me? All right, so the first thing I'm going to do is I'm going to just I want to tin the end of this black wire, which means adding some solder. So because that's the one that's going to go into the breadboard, and I want it a little stiff. So I just want to get some lead right on there, and then it'll poke into the breadboard a little bit easier than stranded wires. There, okay. That's all I'm doing with the black one. But the red one, I'm gonna attach to the switch. So I'm going to use this yellow wire. Doesn't matter what color, but I'm gonna use this wire. This will plug into the breadboard, and it'll be the middle here. So I'm gonna put that right there. And I'm gonna solder it in place. There's one. And I'm gonna attach the red to anything else. So I'm gonna use this top one. I'm gonna bend this into a little hook. Put that in place. Put some tension on it. There we have it. Extend my solder and we'll just attach this here. Now my switch, my power is just split at the switch. That's all we've done. We've just taken the red battery and we've split it at the switch. It's pretty neat. So I can go back to my workspace. Okay, so here it is. I got my soldered switch. I'm real happy about it. I'm just gonna lay it down to just wait because I still have to connect all the jump wires, the little wires that connect all the things to each other. And I'm gonna make them. I just wanna show you how fun it is to make your own jump wires. So I just make all these like little U-shaped wires. I clip it, and then I do that. So let's just say like I wanna do this plus channel to F2. I can do F2, put that in place, and then bring that over to the plus channel. There it is. That is in. It's in. Then I need some little ones. Let's see, this is the one I'm cutting on, so I will cut the tip, bend it to about the size I need. Reduce the tension. There. And then I can just plug this in. This is going in at A5 to negative. A5 to the negative channel. And then I'm gonna do A8 to the positive. A8 to the positive. Gotta make sure it goes in, so I gotta bend it a little and get it in there. A8 to the positive, very good. Now I gotta do this long one that goes from this F12 to the negative. So if I've got F12 and I've got to come over here to the negative, that's where it's gonna bend. So there. Get those capacitors capacitors all the way to the negative there. Grounded. And then I got a channel over. See how there's a wire over? I'm going to make that bridge. So I'm going from G7 over to D6. So G7 to the 6. There it is. There. Pretty great. Now, what I have left to do are the outputs. So I'm going to start with the negative. The ground output can come out anywhere on the ground. So you put this in the negative, and this is going to be where I'm gonna, I gotta solder my banana plugs and decide where they go. So for now, I'm going to just mark my outputs and then figure out how long they really gotta be in the long run. So right now, just so you know where the juice comes out, the positive is at D4. So D4, yep, right here. D4 will go to the red banana plug. So I need to add some wires to this, and then I'll be set to plug it into this. So there's the circuit, the completed circuit. It's all there.